Welcome back to another Micro Soldering Wednesdays. My name is Derek and today we're going to be going over an iPhone 14 Pro that will not activate. When you go to try to set it up, it just fails and it gives you an error. Most of the time this is caused on the newer models from a hard drop. What tends to happen is the top and bottom board split. This can result in a bunch of different issues like searching no service, Wi-Fi issues, Bluetooth issues, and a bunch of other things simply from a drop. Let's take a look at this phone and see if it can be fixed. We have an iPhone 14 Pro here that cannot be activated and it keeps restarting. We can see this error message that indicates that the activation data has failed. We'll remove the motherboard from the case and take a look at it from the side. Viewing the motherboard from the side, we can clearly see signs of deformation. In order to separate the sandwich boards, we're going to use a temperature of 160 on the heater and 370 on the heat gun. And then we can split the boards and set it down to cool off. We observe that there are several solder joints broken on the mid layers on both sides, and given the severe deformation of the motherboard, it will be much easier to do a board swap and swap over the crucial components from one board to the other. Those components are the Wi-Fi, Baseband, CPU, EEPROM, Let's start with the upper layer of the old motherboard and carefully remove the CPU. Going around the perimeter of the CPU with a temperature of about 280 Celsius, we'll be able to remove the underfill that surrounds the CPU. We don't have to be extremely careful because we're not saving this board. Now that we have the underfill scraped off the edge, we're going to take our heat gun up to 400 degrees Celsius and carefully heat it up. We'll move out of the way any of the components because we don't care about the top board. And we'll lift off the CPU. And we'll proceed to remove the Wi-Fi IC as well in the same manner, carefully going around removing the underfill so that we can split it from the board. And then back up to 400 degrees to pop off the IC. Now let's remove the shield so we can access the EEPROM. Add some flux. You definitely don't want to pull any of these pads or damage this IC, because if this IC gets lost or damaged, it's game over. We'll now remove the baseband chip from the lower layer because this is also paired. So using 280 Celsius, we'll go around and carefully remove the underfill. and then up to 400 degrees Celsius to remove it as well. When it comes to the donor boards that we're going to be using to transplant these onto, the easiest method is to grind off the ICs. So there will still be a little bit of the border remaining of each one of the ICs as we go over it, but we at least didn't have to apply heat in removing them yet. So using a 138 solder paste, we'll be able to go around and add solder to all of the joints under these ICs, not only mixing with the factory solder, but allowing for us to be able to remove the underfill and wick away the factory solder, leaving us with a completely flat surface to solder the new IC to. So we'll remove the remaining sections of the IC and the underfill that surrounds that area, completely prepping it for the new IC. Using our soldering iron and some wick with flux, we'll be able to go in and scrape away the remaining underfill all the way out to the perimeter. We'll do the same thing on the CPU area, adding some 138 to the factory solder, using some flux, hot air, and our soldering iron. We're going to move it around and start to get to the edge with it so that we can remove the remainder of the old CPU and mix with the solder that's factory on the logic board so that we don't pull any pads or damage the board. Go ahead and wick all of the pads, get rid of all of the solder. And then using our heat set at 230 Celsius, we'll carefully go around and scrape up any of the underfill that is still where the IC needs to go. And there goes one section of the CPU. And there goes the other. Now using tweezers, we'll gently remove the adhesive around the edges, ensuring that the edges will not touch when we go to solder the CPU back on. And removing all the underfill between all of these smaller components will also help cause them not to potentially float. Even though they'll look like they're in a nice spot, they might not actually be physically connected. So removing that underfill will ensure that that doesn't happen. We'll now apply some 138 to the solder pads where the Wi-Fi module will go on this new logic board, and do the same process where you can see the perimeter of the old Wi-Fi IC is still there. We'll be able to carefully remove it. And something also where the EEPROM is, you'll notice that we've grinded away the frame so that we'll have better access to it without having to desolder the shield. We'll add some flux. And we'll take some wick and suck up all of that solder and remove all the remaining underfill all the way to the edges. Now we'll thoroughly clean all of the solder joints with some isopropyl alcohol and a Q-tip. You can also use a clean room wipe with a brush or other things that you might enjoy. And here we're going to remove the EEPROM that's crucial for the function of the CPU. This one we don't care about, but we do need to remove it. And we'll also need to make sure we do the baseband data transfer. So now that we have the baseband off, we'll be able to make contact with this jig that'll help us to read and write the baseband code. We'll just double check that it's read. And then we'll plug in our new board. Make sure it sits properly, and we'll write to that bottom board. And there we go. Just double checking, and we're sure that it's written. We're going to apply some 138 solder paste to help loosen up the underfill that's under the IC, along with some flux here. And this will also help us to remove the factory solder so that we don't damage any of the pads. Basically allowing the soldering iron to glide on top of the IC without really making contact with it, pulling the solder along, getting the solder to pull up. And we're going to do the same thing with the Wi-Fi IC, adding some 138, going around with some flux, pulling up the factory solder. Now using our hot air at 280 degrees, we're going to carefully remove the underfill without scraping the bottom of the CPU. We want to remove all of the traces of this underfill, otherwise it might cause a high point and make it so that the solder joints don't pancake out when it comes time to solder them. We'll clean it up with some isopropyl alcohol and a Q-tip. We'll take it back to the jig, and we'll do the same thing to carefully remove any traces of underfill remaining. And on the baseband IC, we're going to go around and cut off the underfill that tends to stick to the edge of this IC. And same with the Wi-Fi IC. Now we're going to use our stencil with high temperature solder paste for the CPU. We'll align the CPU with a stencil and smear the solder paste into the stencil. And we'll come back with the clean room wipe and wipe it up. Not only does this kind of help absorb the flux, but it compresses the solder down into the stencil. And then with 300 degrees Celsius, we're going to carefully work across the IC until we've got a perfect reball of the CPU. And we'll carefully pull it away from the stencil, and that flux tends to stick a little bit sometimes. And here's a close-up of the reball. Nice even solder balls all the way across. And we're going to do the same thing with the Wi-Fi IC. And with 300 degrees Celsius, we're going to carefully go across and reball the IC. And here's a close-up of that. Now using the tissue paper again, we're going to reball the baseband IC. That tissue paper allows you to get kind of a valley where when you put compression on it, you're going to have less warpage when you heat up the stencil. So at 300 degrees Celsius, we're going to carefully reball the baseband IC. There's a look at that. Now we're going to carefully go over and apply a flux, an even coating of flux. This will help keep the solder from oxidizing when we heat it up from above. So we want to make sure we have an even coating of flux on the IC side, and we'll also do the same thing when the time comes on the motherboard side. We don't want any cold solder joints where it's not actually making physical contact because the flux wasn't there to shield the solder from oxidizing. Now here's where the EEPROM goes. Refer to a schematic if you forget the orientation. We'll add a little bit of flux and carefully line up the EEPROM, making sure we get that dot and that corner. A lot of the times you don't have to reball these because of the way that they come up, but if you notice an uneven solder on the bottom, you'll want to reball it. But the less you can mess with the EEPROM, the better, because of how sensitive it is of an IC. We heat it up to temperature and nudge it, and we'll see it stick, and we know that we're done. Now we're going to do the same thing. We're going to add some flux, and we're going to coat all of the solder joints under where the CPU is going to go with flux so that it too doesn't oxidize just like the solder on the CPU. We want a nice thin coating of this, so doing it in this manner will ensure that we get a nice thin coating all the way across the CPU. Now there's a couple ways to do this. There's some thinner liquid fluxes that work well, but this is just one of those ways to do it. We'll align the CPU with the solder joints, making sure that we also have it in the proper orientation. And once we're perfectly satisfied that, we'll isolate it by putting this high temperature tape next to it. We'll take our rework station up to 400 degrees Celsius and carefully flow it into place until we can get a little bit of a nudge and a snap back of the CPU from the side, just like that. Now we're going to take a power supply and connect it to the motherboard to make sure we get a normal draw when we go to prompt it to boot. And because we didn't swap over the NAND, what we'll be seeing is the phone go into DFU with that 0.082. This is normal. We'll connect it to the screen and insert a battery to connect it to computer so we can flash it to ensure that the soldering went well for the CPU. We'll connect it up to 3U tools in DFU mode, and it identifies the model, which is good at 14 Pro, and we'll flash it. But we won't be able to go past 55% because we don't have the bottom board, and so it will fail on any time it attempts to do anything with baseband. So we'll need to finish the repair up before we go back and do a final flash, especially because we haven't moved over the NAND. We will want to do that. Now if you wanted to take the time to move over the NAND, then we wouldn't have to do that. This is also a good way to upgrade the memory on this model. If you have a board that you're swapping it to that has a higher memory, you can do that. So we'll line up the Wi-Fi IC using 400 degrees Celsius. We'll go ahead and get it lined up and get it to snap into place. With a little nudge and a snap back. We're going to use some high temperature copper foil to insulate the surrounding area for the baseband. Going to add some flux so that we coat the solder joints down there so they don't oxidize under the 400 degrees Celsius. Once we have an even coating, we can then apply the IC to it in the proper orientation. Again, if you haven't marked it out, refer to a schematic. And at 400 degrees Celsius, we're going to carefully go around just like we have so many times before and get it to snap back into place with a teeny nudge once we see it kind of shift into place. And then we'll let it cool down. Now it's time for us to reball the mid and bottom boards. So we're going to add some flux, go around with some low melt so that we can remove the factory solder easier. And we'll do this all the way around the border. And we'll clean it up really well with a cotton swab. Now at this point you could wick it further or you could go straight to reballing because we don't really care about the temperature. We're going to be taking this down anyway. So we're going to now add some solder paste evenly to the stencil here. And then we're going to clean up any of the excess and push down the solder paste into the stencil. And clean out along the SIM card reader, and then we'll carefully lift the stencil up, and if we've done this properly we can go straight to applying heat and the solder will come together on each one of those pads, forming a nice solder ball as we do this. And we're going to go ahead and add some flux around the perimeter, so that when the time comes to solder that, we have a nice clean shiny solder paste, so that we have nice clean solder, to stick to the top board. And we'll line it up. Once it's perfectly aligned, there's two ways to do this. Because it's a 138, we can do this with a rubric station, or you could set it your hot plate to like a 150 or 140 and do the same thing. Well, we're going to go ahead and carefully just go around until it goes down with the rubric station. Clean up any flux that we see on the sides, bottom, around anywhere that we can clean up, we'll clean it up. We'll go ahead and install it back into the frame, reconnecting all of the components. Once we do that, Once we do that, we'll be able to connect it up to 3U Tools and do a proper flash with everything connected to get it to properly restore and be ready for activation. And this time, because we do have the bottom board, we will see it go past that 55%, where it otherwise would have just failed. All right, we'll connect it up to 3U Tools, flash it. And there we go. We can now connect to Wi-Fi and set it up. Now this phone was paired to an iCloud account, so we will need the username and password to get past this point, but we are basically done. And there you go, all fixed. Now some of you might think that this is a little excessive of a repair. Keep in mind that the iPhone 14 Pro still has quite a bit of value, and so doing something like this saves somebody from buying a completely new phone. Getting a phone that was either extremely damaged or an iCloud locked motherboard is a lot cheaper, and being able to remove the ICs with something like this gives you the ability to do this type of repair in a much easier way, because you're doing half the solder work that it would otherwise take to do a motherboard swap like that. Now on these new models, given that the NAND isn't paired, it's the perfect opportunity to upgrade memory. Or if you want to put in the extra work to move NAND over, go for it. Leave a comment below if there's something that you'd like to see in a future video. Thanks a ton for watching. We'll see you in the next video.